In Europe, air traffic has been steadily increasing over the past few years and reached pre-2008 crisis levels again. To get an idea of the volume of traffic in the sky across all EU countries, plus Switzerland and Norway, there were 10.6 million flights in 2017, which is an increase of just over 4% relative to 2016. By 2024, around 12.5 million flights are expected. This corresponds to around 34,000 flights every day on average. All of these flights need to be controlled to ensure safety, not only to avoid collisions, but also to coordinate delays to avoid bottlenecks around certain airports or congested regions. So what are the main challenges for air navigation service provision?
Let's first focus on ATC capacity shortage. The Commission recently stated the risk of scarce capacity is the biggest challenge aviation will have to face in the coming years. Air traffic delays this year will be very high, at least 3 times higher than the EU target. The cost of delays above optimum will exceed €1 billion. We are getting close to crisis levels reached at the end of the 90s, which led Mrs. Loyola de Palacio to launch the Single European Sky. What is happening? The ATC capacity issue severely harms the whole network, but is not insurmountable. Capacity issues are in fact concentrated in a few centers who do not provide sufficient capacity at the right time. This is not a general issue. Second, the cost of adding the required capacity in those few centers is much lower than corresponding delay savings. 100 million in additional capacity costs could help save 1 billion in delay costs. It is very clear that capacity has to be added in those places, but it has not happened. How to ensure that sufficient capacity is delivered? Second, there is significant spare capacity at the same time. This graph shows the cumulative distribution of sector load over sector hours in June 2017. Half of sector loads were below 60% and the average load was 62%. At the same time, 7% of sector hours were overloaded, therefore generating delays. As in any network, supply and demand must match. This is the secret to performance. Else, there is both capacity wastage and poor service. How to ensure a better match of supply and demand in ANS? Third, in case of congestion, flights may be displaced not only in time, but also in space through alternative routing. This has costs in both economic and environmental terms. Overall, success can be measured through the total economic costs borne by users for ANS, comprising the cost of service, of delays, and of non-optimal routes. Can the total economic cost be improved, and how, taking into account interdependencies between its components?
We see that change is urgently needed, but how to drive behaviours of both users and providers in the interests of the network? The exploratory research project COCTA is addressing this challenge. The project was funded by the SESAR joint undertaking under the European Commission's Horizon 2020 programme.
COCTA findings are very timely in this respect. Although it is an exploratory research project, its approach and findings provide clues and initial results that could inspire policymakers and future research.
The main idea of COCTA is to work on both capacity and demand side in managing the trade-off between over and undersupplying of capacity. On the capacity side, a network manager asks for airspace capacities in line with expected demand and employs a network-centered demand-driven approach as opposed to the current largely supply-driven and piecemeal practice with predominantly local or ANSP perspectives. On the demand side, airspace users are charged based on city pairs rather than by sectors crossed, so this provides a strong incentive to fly shortest routes. Furthermore, the network manager also offers cheaper trajectory products to aircraft operators that grant the network manager more last-minute flexibility.
What are these flexible trajectory products? To illustrate the idea, let's consider an airline wanting to fly from A to B on a particular day and time. The network manager would offer the airline the permission to fly within given margins of spatial deviation from the shortest route. This offer would typically be made some time in advance of the actual departure day. When the airline buys this permission, they obtain the right to fly a route within these margins. However, it will be the network manager who decides shortly prior to departure on which route exactly the aircraft needs to fly. The charges that the airline needs to pay for the flight permission depends on the margin of flexibility that they grant the network manager. In fact, these margins could be expressed not only in spatial, but potentially also temporal terms. There is no incentive for the airline anymore to fly longer routes to avoid high charge sectors under this new pricing regime. The network manager has an incentive to let flights fly shortest routes unless it is better for the system overall to make use of the flexibility to avoid certain capacity bottlenecks, thereby ultimately saving money for the passengers. In the project, we study the potential improvements achievable through the proposed framework, as well as trade-offs between the different key performance indicators in a large-scale case study. According to initial results, COCTA allows the same traffic volume to be handled with 6% less spending on capacity and 83% fewer minutes of delays. These results were obtained via a simulation study based on central and western airspaces for a single day with more than 11,000 flights.
So in order to measure the performance of our approach, what we did is to build a quite substantially sized simulation study where we essentially had to address various types of decision-making problems. So decisions include, for instance, the ordering of capacity, include the pricing of these two different product types for all the various flights around, and of course also the final assignment of specific flights to their individual trajectories that they should take. The problem with that is that all of these decisions are linked together. They are interdependent in as far as that if I'm deciding to have a particular flight on a particular trajectory, that I'm of course affecting all the different airspaces that this particular trajectory is going through. And likewise the pricing would be influencing the decisions of these aircraft operators as to which particular product they are going for. So it is a quite complex and quite challenging problem that we sought to address, especially because we also have got a substantial amount of uncertainty in there. Uncertainty stems, for instance, from the fact that we do not know all of the flights in the system a priori. So there is business aviation, there's charter flights, etc., that we wouldn't necessarily know upfront about. And there's also uncertainty regarding the actual decision of the aircraft operator. So which of these products are they actually going to choose? So all of these things we need to model somehow and to basically bring into the optimization. The way that we did that is to build various types of heuristics that are scalable to this quite large-scale decision-making problem, so that it's actually able to handle cases of tens of thousands of flights.
Furthermore, air traffic management is a highly regulated domain. Our approach is a major departure from the current system. Therefore, there are many regulatory challenges to overcome.
The provision of air navigation services is highly regulated. We have different objectives in this industry. We want to have an efficient provision of services which leads to low cost. We want to minimize delays, and we also want to minimize the negative impact on the environment. Therefore, we have a regulation already in the current scheme, and within our COCTA scheme, we will also need a regulator. So the ANSPs will have to be regulated, although in a different way than currently, because a lot of the regulation will be in form of a contract in the future, and the network manager will have a stronger role in within the COCTA context, and therefore we will also have to regulate the network manager in a different way than it is today.
In summary, this project has demonstrated the substantial potential for cost reduction in air traffic management provision, which would eventually benefit the passengers. If you would like to find out more, please visit our website. Thanks for watching.